Yeah, comes on everyone. Let's start off. There, this was the last thing that we did, Newton's lens formula. Let's go ahead with the question. Let's say we have a lens here, R1, R2, mu1, mu2, mu3. So medium is different on both the sides. Matlab you can't use your standard lens ka formula. So if you send light rays from the left hand side, the focal length is f1. If you send the light rays from the right hand side, so now it actually matters. If the mediums are different, the focal length will depend on which way you're sending the light rays. And what's the definition of focal length? When parallel rays are incident on a surface, the point where they meet is the focal length. Find focal length of the system if light rays are incident from left and right. So you have to go back to the derivation again. The lens is still thin lens. Think for a minute, then I'll show you one. So if you see, there are two refractions here. There is a first refraction and a second refraction. So you have to use the refraction on the curved surface formula again. You have to go back to the derivation. Since here the light rays are coming from infinity, you will be minus infinity. So remember again, what is mu1 and mu2? Mu1 is the incident Rekha medium, mu2 is the refracted Rekha medium. So for the first refraction, it is mu2 by V minus mu1 by minus infinity is equal to mu2 minus mu1 by R1. This is your first refraction. You actually get a sequence kind of thing. You'll see something. See. For the second refraction, because the lens is thin, we can assume this point and this point are same. So you can ignore the thickness. Now see, the light rays are going into mu3. So mu3 is the refracted medium. This will be your focal length f. That's where the point will meet. And this will be mu2 by v. So the image of the first refraction will be the object for the second refraction. And this will be mu3 minus mu2 by minus R2. This is your second refraction. When you add these two, this term will be anyway 0 because it's 1 by infinity. This term and this term will cancel. You end up with mu3 by focal length is ut minus mu1 by R1 plus mu3 minus mu2 by minus R2. There. You can send that up. That's it and finish it. If you put mu1 is equal to mu3, you will get your standard formula again. Clear with this? Now I can do something even better. Same thing, suppose if it was like this. Mu1, mu2, mu3, mu4, mu5. Someone made a length like this. 5 different mediums. Let this radius of curvature be R1, R2, R3, R4. So if you send light rays from here, let this be F1. Light rays from here, let this be F2. Now look at this logic here, what you got. The focal length from left-hand side will be mu3. Mu3 is the final medium, isn't it? The final medium where the light rays are going by the focal length will be mu2 minus mu1. So you see the light rays, how they're going. Light rays are going from 1 to 2, 2 to 3. So mu2 minus mu1, final minus initial by R1. Then 2 to 3, final minus initial by R2. R1 and R2 are taken with sign convention. You can see that thing. Now using the same logic here, see how it looks. The light rays are going to mu5. So this will be mu5 by F1. Light rays are going from 1 to 2. So final minus initial, mu2 minus mu1. R1 is positive, the center is on the right hand side, so plus R1. Then light rays are going from 3 to 2, so mu3 minus mu2. R2, that is also positive. Then light rays are going from 4 to 3. R3 is a negative sign because look at R3 ka circle. R3 ka center is on left hand side. And then mu5 minus mu4 by minus R4. Making sense? Can you write for F2? Try, I'll give you 30 seconds. If the light rays are going from right to left, can you find the focal length? That's your formula. You see which way the light rays are going. So if you're going from right side, it is 5, 4, 3, 2, 1. You can have a weird lens like this also with 5 mediums. Check. Light rays are going 5, 4, 3, 2, 1. So final minus initial. So 4 minus 5, 3 minus 4, 2 minus 3, 1 minus 2. All clear with this? And R1, R2, R3, 4 will be the sign convention. In the direction of the light rays, you take it as positive. So this is a general formula for this thing, but yeah, you should know how to derive though. Refraction on curved surface, you just do it 2 times. Add them, they'll cancel off. All clear with this? So this is one model where you can't use your regular lens ka formula if you mess up the mediums on both the sides. Quite an important question. Next one. We got a lens here. Focal length is 10 centimeters. Another decent question. This will be actually a question in wave optics. Maybe we'll use this at a distance of 30 centimeters. Then what you did, you removed 2 centimeters of lens from the middle. You removed 1 centimeter above the principal axis, and you removed 1 centimeter below the principal axis. So you removed 2 centimeters. And then what you did, you clubbed them. After removing it, you joined the two lenses. The object is still at the same place, nothing changed. Find the images, and the remaining parts are joined. Find the position of the image. Something happens. If you remove a part of the lens, does focal length change? That we saw, right? Even a part of a lens will still create an image at the same place. Yeah, Aditya. So if I take the full lens, or if I take a part of the lens, the image will be at the same place. Yeah, intensity will change. So that is not the problem actually. So cutting the lens was not the problem. You know what was the problem? Initially, this was the principal axis. So if you cut the lens and keep it there, there is no problem. But now what you did, you brought it down, isn't it? When you combined them, the lens moved downward. So what you did, you messed up the principal axis also, isn't it? The principal axis got shifted when you combined them. So cutting the lens didn't create a problem, but when you combined them, you moved the principal axis. And because of that, suddenly something like this happened. So this was the old principal axis. This is the first half of the lens. You cut this piece and you brought it down. So for this guy, the principal axis became this one. And for the lower part, when you did this, this became the principal axis. Did you see what happened? You created two different principal axes. That is wrong, Rakush. And the object is still there only. So the principal axis started thinking the object is 1 centimeter above the principal axis. Are you getting this? That's what actually happened in the problem. Cutting the lens didn't create a problem. After cutting, if you had just left the problem there, after cutting, if you had left the gap here like this, nothing would have changed. The answer would have been same. By combining them, you messed up the whole thing. So when a lens is cut, the focal length remains same. And the principal axis remains same. So let's say this was your principal axis, and just write it as old axis. This was the upper part. This was the lower part. So the principal axis also would have remained there only. But now what you did, you brought the red one down. The principal axis got shifted here. So object is here. So 1 by V minus 1 by U, which is minus 30, is 1 by 10. So we got V is equal to 15 centimeters. Magnification is V by U, which is minus 15 by plus na minus half. So this is your new principal axis for the red lens. And this principal axis will think the object is 1 centimeter above the principal axis. And this will create an image at a distance of 15 centimeters. And minus half meaning other side of the principal axis. The image will be here. This will be half centimeter. Is that making sense? So from the initial line, it is at what distance? 3 by 2, na? It is not half. It is half from the new principal axis, but from the old principal axis, it is 3 by 2 centimeters now. Similarly, the same thing, if you do the green one, when you made the stick here, this became the new principal axis. So the image will form somewhere here, I2. This will be half centimeter and this will be 1 centimeter. So your final answer will look like this. The green ka image will be here, the red ka image will be here, and the distance between them is 3 by 2 centimeters and 3 by 2 centimeters. So we get two images at a distance of 15 centimeters separated by 3 centimeters ka gap. Clear, everyone? The most common mistake, half you will get, that is right, but half is from the new principal axis. And you shifted 1 centimeter below. So the old principal axis is already 1 centimeter above. So total becomes 3 by 2. This problem, again, we will use it in wave optics later on. So then the question will be like this in wave optics. There's a screen here. There is something called YDAC experiment, Young's double slit experiment. Then there is something of that sort. This will be a part of that question. Clear with this? Not tough one, but you need to realize when you cut a lens, there is no problem. But if you move the lens, that is when you created the problem. Clear with this? Most people focus too much on cutting the lens. The thing is that didn't create any problem. When you joined them, you messed up the whole thing. Any doubts on this? It's a good one. Clear? That is a bit about lenses. The next thing is combination of lenses. What happens if you have multiple lenses and multiple mirrors combined together? So we will define something called an optical power. This is something with people with glasses. We keep realizing, we keep hearing this thing. People ask you, right, what is your eyesight? Like my eyesight is -5, right? I keep saying that my power of my glasses is -5. So what is the meaning of that exactly? So when you say optical power, remember, this is nothing to do with your mechanics ka power. This is an ability to converge or diverge light rays. So converging systems have positive power. If a system is converging light rays, we say it's a positive power. Diverging systems have negative power. So when I say my glasses ka power is -5, most people, right, who have myopia, right, we use negative power lenses. So what is actually happening if you look at your eye, and this is your retina, so retina is your screen. This is what is happening with people with myopia like me. The light rays which are hitting this ICAL lens, they're not forming on the retina, they're forming in front of the retina. So these light rays, right, so what you get is a blur. The image doesn't look clear, it looks like a blur. It kind of looks like this. This is how the images will look. If you remove the glasses and see outside, the bulbs will look like this. The reason you're not getting a sharp image, you are getting a blur. Everything looks, got distorted. So this is what we call as myopia condition. So the thing is the light rays are meeting even before the retina. So what we do, we put a diverging lens. So what this lens does, light rays will come till here. This will diverge the light rays a bit. And then when they go through the eye, they converge at the back, a little below. So that is how we do the correction. So when you go to a doctor and you're getting your eyes tested, this is what they do. They put a glass and they'll ask you, can you see better? Or this is better. Ever if you've gone for eye checkup. And at some point you will feel like, this is good. So that is how they realize, okay, this is your eye power or something. Similarly, people with the other condition, right? Generally, this happens in old people. I forgot the name, it's something else. So in this case, the light rays actually meet ahead of the retina. Even these people can't see clearly. So long-sightedness basically. So here we use converging lenses. So here the light rays are made to converge before. Hypermetropia. Yeah. Getting it. So this is what actually happens when you're wearing glasses. You are using converging or diverging glasses. When you say my power is -5, the minus indicates I'm using diverging lenses of power 5. We will see how to study that power ka thing. Ever heard about this thing, LASIK surgery and all? People go for this LASIK surgery. So what they do in that surgery, on your eyeball, you have a cornea. Cornea is a thin film, right? So what these people do with the laser, right? They take the laser and they start burning off this cornea, basically. They start reshaping the cornea. So when they reshape this cornea of different radius of curvature, you're messing up the ARGA value. So when you mess up the radius of curvature, what will happen? So think of like this, your eye is one, your cornea is another lens actually. So they're reshaping the cornea to create a lens on top of your eyeball. So they will keep burning off this, using that laser, they burn off a part of a cornea. They reshape it. And they keep on reshaping it till the focal length matches with your retina thing. So indirectly, they're creating a lens out of your own cornea. So that is the reason some people, right, first of all, when you go, they check for the thickness of the cornea. If your thickness, you don't have enough thickness, they can't do the surgery. Meaning they have other types of surgeries, but this is one of the types. And the same reason, once you got a LASIK done, you can't again get it second time, generally because your cornea is already pretty thin. Right? So people who don't have enough thickness, they do something else. They put a lens inside and they stick it to the glass and they do some kind of thing. That's a different surgery. That actually leaves a small scar, but yeah, it's not visible. So that is how the LASIK goes. Basically, they use a laser to burn off a part of your cornea to reshape. That is, they're changing the radius of curvature, so focal length changes. That's what happens in a LASIK surgery. Right? And yeah, it kind of works. That is there. Happens pretty fast. They just do it in minutes. And again, normally it is expected, you don't get it done. Now, if you go and ask them, they'll not do it to you because you're still growing, your eyesight will keep growing. Mostly after around 21, 22, it stops. My eyesight grew very rapidly. Like I got it in 6th standard, I think, with a -1.75. I started from there. By the time I reached 12th, it was almost 5. And then it stopped. 5.5 it became 5.25 now. It stopped. It has been almost 15 years. It didn't increase. After 22, 23, it stops generally. So as long as you keep growing, it grows with you. So how do we define the power of the lens? So the lens ka power, right? We define it as 1 by focal length of the lens. This should be in meters. and the units are diopters. So when I say -5, it's actually -5 diopters. That is the unit. So for a lens, this is the power. 1 by focal length of the lens in meters. Example, if you take a lens here and if you say focal length is 20 centimeters, then the power of the lens will be 1 by 0.2 meters, which is +5 diopters. Similarly, power of the mirrors. Remember, converging systems are positive. In a mirror, a concave mirror is positive, but concave mirror ka focal length is negative. So to make it positive, we introduce a minus sign. Here also F should be in meters. So if you have a convex mirror, let's say radius of curvature is 20 centimeters, then the focal length will be 10 centimeters. You should take with signs. So power of this mirror will be 1 by 0.1 or with a minus sign. So it's -10 diopters. This is actually a diverging mirror. Clear with this? So be careful with the minus sign. Mirrors mein there's a minus sign, lens mein there's no minus sign. That minus sign can goof up a lot of things. Next thing, combination of lenses. So what happens if we keep a lot of lenses together? If you have a lot of lenses, f1, f2, fn, again, we are assuming the lenses are very thin and the distance between them is negligible. Then we can use the formula 1 by v1 minus 1 by u is 1 by f1. Since the distance are negligible, you can take the distances directly. So on 1 by vn, you get a telescopic function. When you add all of them, v1 will cancel, v2 will cancel, and so on. You'll be just left out with 1 by vn by 1 by u is equal to 1 by f1 plus 1 by f2, so on till 1 by fn. So you can write 1 by f equivalent. This is nothing but power of the system. So all this thing can be replaced with one single lens. P1 plus P2 plus P, and you can just add up the powers. And this whole system behaves like a lens. So if you take a lens of 2 and if a lens of 3 and add them, you get a lens of 5. It just adds up. Be careful, these are valid only when they have common principal axis and the lenses are thin. If they have distances, you can't do this. You have to go back to solving the problem regularly. Use the lens ka formula n number of times. Valid for thin lenses and a common principal axis. Clear? What happens if you have lenses and a mirror? Let's say we got a lens, and we got a mirror. They're very close to each other. I'm just drawing like this. P1, P2, power of the mirror. So here, if you see the light ray entering, it passes through lens 1, lens 2, hits the mirror. Then again comes back, lens 1, lens 2. That means this thing is behaving like lens, a mirror, and again two lenses. So every time you have like this, it feels like you're passing through 4 lenses. Double the lenses basically. Remember, in our sign convention, the direction of light ray is always positive. So light ray doesn't know, it thinks it's just going straight. So this power of this combination and this whole setup behaves like a mirror. Is given by 2 times P1 plus P2 plus 1 mirror. So if you have lenses, to 2 sigma P lens plus PM. So how do you know whether a system is behaving like a lens or a mirror? There's one very important difference between a lens and a mirror when the light rays go. This is clear, everyone, this page? Let's say if you have a lens, you have a lens, and you have a lens. Multiple lenses, doesn't matter. You will notice this thing. When a light ray goes through this lens, did you notice something? It just keeps going straight, meaning it never turns back. But let's say if you have a lens and if you have a mirror, the light ray goes, it again comes back towards the initial direction, isn't it? That's your major difference. In a system, if the light ray turns back, then it is a mirror. In a system, if the light ray just keeps going in one direction, it is a lens. That is how you know if a system is behaving like a mirror or a lens. Generally, if you have odd number of mirrors, if you have one mirror, it is always a mirror. I'll show you a case later on, but generally this thing people don't get confused, but there's a case where you will get a confusion. So combination behaves like a lens if the incident ray goes in one direction or incident ray just keeps going forward. A combination behaves like a mirror if the light ray comes back. Need not retrace the path. You got the point. The angle becomes light ray reverses. It comes towards the direction of the object. So if the whole system is behaving like a lens, then your formula will be, now this idea is important because or else your formula will be messed up. If the whole thing is behaving like a lens, then the formula is 1 by V minus 1 by U. If the whole thing is behaving like a mirror, it is 1 by V plus 1 by U. So depending on how it is behaving, whether it's a lens or a mirror, the formula will change. Clear with this, everyone? If you take lens ka thing as a mirror and then do it, the whole thing will goof up. You'll get a sign ka issue there. That's the theory there. So whenever you do problems like this, step 1, find the power of each lens, right? Power 2, find the combination. Step 3, then find the focal length. Step 4, then it becomes your regular problem. Let's say a question that will give you an idea. So we have a lens 10 centimeters, 20 centimeters. Object is there, 20 centimeters. Find the position of the image. Same thing, lens, but this time you silvered it. So whenever they give these kind of problems, right, when they silvered it, what you can do, you can just assume a thin air gap between the silvering and this thing. It works. Because see, if you have a thin air gap, the thin air gap behaves like a lens whose power is 0. Because 1 by f will be mu lens minus mu medium minus 1. This is 1 minus 1 is 0. A thin air gap behaves like a 0 powered lens. So you can always separate that. We can assume a thin air gap. So even if you stick two lenses, you can always do that. You can always separate them with a thin air gap. There. Find the position of the images. Easy stuff. Get it. Just formula substitution there. Nothing much. Get the equivalent focal length. Use the formula and you're done. Right. I'll give 2 minutes for both. So what is the 1 by f equivalent? 1 by 10 plus 1 by 20. I can do this directly. This is 3 by 20. So this whole thing is behaving like one lens whose focal length is 20 by 3. So 1 by v minus 1 by u, which is minus 1 by 20, is 3 by 20. So we get v is equal to 10 centimeters. And that's it. So just replace all this thing with 20 by 3 and you finish it up. Clear? What about this guy? If you have a lens and a mirror, when I get these kind of questions, I would prefer to use power because that 1 by f1, 1 by f2 doesn't work for mirrors ka thing. You can do minus 1 by fm and all, but I get confused, so I don't do it. So this is 1 by f1, that is 1 by 0.1, 10 diopters. Power 2 is 1 by f2, which is 0.2, 5 diopters. Focal length of the mirror, radius is minus 20 centimeters. Remember, it's a concave mirror. The focal length is minus 10 centimeters. So power of the mirror is minus 1 by fm. So be careful with the signs. Concave mirror is converging, power has to come positive. That's one way to remember. Plus 10 diopters. So this power of this whole combination is 2 times P1 plus P2 plus PM, which is 15 plus 10, 40 diopters. And this whole combination behaves like a mirror. So power of this mirror is 40 diopters, which is minus 1 by FM. So focal length of the mirror is minus 100 by 40 centimeters or minus 5 by 2 centimeters. That means this whole setup is behaving like one concave mirror whose focal length is minus 5 by 2 centimeters. Object is here at 20 centimeters. There, once you got till here, then it is just a matter of using the mirror ka formula. 1 by v plus 1 by u, which is 1 by 20, is minus 2 by 5. Multiply 4 there, that will be minus 8 plus 1. So v is equal to minus 20 by 7 centimeters. Check my calculations. Right, Niharika. We both got same. Maybe right. So there, that's your image. Clear, everyone? You just be careful with the signs. Power of a mirror is minus 1 by fm, and then when you again bring the mirror to focal length, again minus 1. Focal length is negative. The negative sense, you have to be careful. All got this? So that entire setup is replaced with a concave mirror of minus 5 by 2. Once you got here, then it is over. It's your regular question then. Any doubts on this? Let's see, one more. This was a mains P by Q. Easy one. We got a lens, mu is equal to 2. This power is 2 diopters. You took this and immersed in a liquid. Four by three, 4 by 3. What is the new power? This is what actually happens. When you get into a swimming pool, the medium outside changes. Your power of your eyes change actually. So vision actually gets blurred. Even if you wear that goggles, still it gets messed up. You can't see inside the water that clearly. Yeah, this was a mains PYQ. R1, R2 are not given. You won't need them. Any answers? Right, Ishana. Nee, Aditya. Wrong. What is first one ka power? 1 by F1, which is 2 minus 1. 1 by R1 by 1 by R2. I don't know what is R2, R2. That is okay. P2 is 1 by F2. Here this becomes 2 by 4 by 3 minus 1, 1 by R1 by 1 by R2. So R1, R2 won't get affected by the medium. So divide them. P1 by P2. This will become 1 by, that will become 3, 2 by 6 by F. This actually becomes 2. Therefore, P2 is P1 by 2. P1 is 2 diopter, so 1 diopter. Easy? Why are you guys getting so many weird values? Ansh got 1. Erika got 1. Others all messed up. See where you guys went wrong. Clear? So the R1, R2 won't matter. That's the only thing in the question. So So we got two lenses stuck like this with a silvering here. We have two lenses with a mirror there. So object here, this is X. Find X if the final image is on the object. This is the fourth time using something like this. And I told you, whenever you are sticking lenses like this, the one confusion comes like this. Sir, for here outside is one, here is a different medium, here is a different medium. How can you use the lens formula? Technically true. You can't use the lens formula directly. So what we always say is, assume there's a very thin air gap between the lenses. So once you treat like that, it won't be a problem. You can do this. You can assume thin air gaps. And think about it, why it works also. If you take a thin air gap, look at this radius. This is R. This is also R. Look at the formula here. 1 by F. It doesn't matter which medium also you take. What is the radius there? 1 by R minus of, that is also 1 by R. That term will always cancel out independent of refractive index. Power will be 0. So a thin air gap does not create any power. So it works. You can always do this. You can assume thin gaps of any medium you want. It doesn't matter. Independent of mu, that R and R will always cancel. So anytime you get that confusion, you can remember this discussion here. Finish off it straightforward. 25, 80. I don't know. 20. You have three different answers. Did you guys do double the lenses? Lenses will be at doubled. The light rays will go through two lenses, mirror, then again two lenses. So total four lenses. That looks right, Niharika. 20 looks right. Right, Poroja. Same story, find the power of the lenses. So first one ka power 1 by 10, 10 diopters. Second one ka power minus 1 by 40, minus 2.5 diopters. Here the radius is plus 40, focal length is 20. The power of the mirror is minus 5 diopters. Minus 1 by F. Don't forget the mirror ka formula. So power of the system will be, and the whole system behaves like a mirror because rays are coming back. 2 times P1 plus P2 plus 1 mirror. That's 10 diopters. This will be minus 1 by FM. So focal length of this will be minus 10 centimeters. So this setup is behaving like a concave mirror whose radius is 20 centimeters. Now you tell me, for a concave mirror, where should I keep the object to get the image at the same place? At center. Therefore, this X must be 20 centimeters. Easy? Yeah. That is a story every time. Find the power of the combination, see how it behaves, and then just use your regular stuff. Any doubts on 47? Clear, na, Devansh? Arnav? Om? Aditya? Arush? Saish? Vivan? Great. Let's see one more. We got three lenses here. R1, R2, R2, R1, mu1, mu2, mu3. R1 is 10 centimeters. R2 is 20 centimeters. Mu1 is 2. Mu3 is 3 by 2. Find mu2 if the power of the system is 0. What do you mean by 0 power? Zero power meaning there is no divergence, there is no convergence. Light rays simply go the way it is. So an example is a slab. If you take a slab and if you send a light ray, yeah, there is a lateral shift, but it will come out parallelly only, right? The light rays will simply come out parallelly. There is no divergence, there is no convergence. So if you wear your glasses with 0 power, they will look cool, but they don't have any purpose as such. Your sunglasses have 0 power. Get this straightforward formula substitution. What's the focal length of the first lens? 1 by f1 mu1 minus 1, that's 2 minus 1. 1 by r1, that is minus of 1 by 20. Remember, r1 is negative. The center is on the left hand side. This will be minus 3 by 20. 1 by f2 will be mu minus 1. 1 by 20 by 1 minus 20. 1 by f3 is 3 by 2 minus 1. So power of the system will be P1 plus P2 plus P3 is 0. So indirectly 1 by f1 plus 1 by f2 plus 1 by f3 is 0. Minus 3 by 20. Mu minus 1 by 10. Minus 3 by 40 is equal to 0. This will be how much? 3 by 20, 3 by 40. Multiply 2, 6, 9 by 4 plus 1, 13 by 4. Check. Clear with this? Nothing there. Find the focal length 1 by f. Be careful with the signs. Lighters are going from left to right. So R1 is negative. This R1 is negative. This R2 is positive. This R2 is negative, and this R1 is positive. Be careful with the sign convention. This center is this side. This center is this side. This center is this. This center is this. So always check like that. Where is the center? Any doubts on this? Let's say something a little more tricky. This thing is fine. What if you have a system like this? You have a lens. So light ray, a parallel light ray comes inside. It bounces, 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 and goes outside. Basically, there is a total internal reflection. So because of TIR, the light ray is bouncing inside the lens and it comes out. Let this be R1, let this be R2. In case 2, the light ray bounces, 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 and comes up like this. Find the focal length of the system. So a parallel ray enters a lens. And due to TIR, and bounces due to TIR. Bounces inside the lens due to TIR. Basically, the surfaces start acting like a mirror. The writer doesn't know what is TIR and what is a mirror. Find power of the system and the focal length. Think how you approach this. This is a type of question where it's little, you have to think, but it is easy to solve. So you can think of like, this is a case where you have multiple mirrors. So this thing now, if you think about it, every time there is a TAR. See, first of all, what is a lens? Think what happens in a lens. In a lens, the light ray enters and light ray leaves, isn't it? So a lens is nothing but a combination of two refractions, an entry and an exit. So here, the lens is entering, here the lens is leaving. This is your first refraction. This is your second refraction. So this whole setup, right, behaves like one lens. Great. Plus, there is one reflection, second reflection, third reflection, fourth reflection. So there are 4 reflections and 2 refractions. So the 2 refractions together, I can treat that as one lens plus a combination of 4 mirrors. So we got a mirror R2, R1, R2, R1. So the whole system behaves like what? Lens or a mirror? The light ray is still going ahead, isn't it? The whole system behaves like a lens. So we have power of the lens plus 2 times power of mirror 1 plus power of mirror 2. And this whole setup behaves like a lens. It is 1 by f lens. Clear with this? You can find those powers and all. I'll leave it to you. Got the idea? Second one, do it and tell me what you'll get. First one is actually kind of easy. Second one, there's a trap. Let's see if you can figure it out. You even figure out the trap? The trap in this is the light ray enters, bounces, 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 comes back. Great. Can you tell me how it entered and how it left? It entered and it left from the same side. So this is behaving like a lens, agreed, but both the sides have radius R1 and R1. In the previous case, the light ray enters from R1 and leaves from R2. So this is R1 and R2. Are you getting the difference? In problem A, the ray enters from R1 and leaves from R2. So that is the lens R1, R2. But in the second case, the light ray enters and leaves both from R1 only. So it's actually made of a lens, which is both the sides are R1 and R1. Are you clear with the difference? Because see, the light ray does not know what is lens and all. It simply thinks, okay, a combination of these two is one lens. And plus it has only 3 mirrors. If you have odd number of mirrors, the system behaves like a mirror. Light ray is going back. R2, R1, and R2. There, this is a big trap, huh? Most people take R1, R2. That's not R1, R2. It's R1 and R1. The whole system acts like a mirror. Lens plus 2 times mirror 2 plus 1 mirror 1. And the whole thing is minus 1 by Fm. Is that clear, everyone? That's the thing you have to be careful. It's R1 and R1. Take a break. Come back by 9:41. Any doubt so far?
सर वन डाउट
बोल लो.
सर एक हमने यहाँ पे एक रिफ्लेक्शन के लिए एक मिरर लिया तो लाइक जब एंड में लास्ट रिफ्लेक्शन होगा उसके बाद एक रिफ्रैक्शन होगा
1,
बाहर
2.
चले जाएंगे।
ओके,
लेकिन ए पार्ट में तो वो लास्ट में वो एक और लेंस नहीं नहीं ऐड करेंगे क्या उन लोग, मतलब
कहाँ
लेंस,
पे लेंस?
पहले लेंस से रिफ्रैक्ट किया अंदर, फिर
So you
lens
mean to say this is just lens? This is lens or this is lens? लेंस में कितने रिफ्रैक्शंस होते हैं दुबे आदित्य?
अरे राइट, मतलब हाँ ठीक है समझा।
There are two refractions, isn't it?
यस,
One, two. वही तो था ये two.
अरे हाँ ठीक है समझा, थैंक यू।
Yeah. चलो, come back in 5 minutes. So that's a bit about combination of lenses. Then we have a few theoretical things. This we will not do any derivation, but they did ask a lot of times in mains and these kind of exams. I remember seeing this in CET actually. Equivalent focal length. So if you got a lens and if you got a lens, focal length is f1, this is f2, and if this is d. So this whole thing can be replaced with one single lens. Where 1 by f equivalent, so this is the most important one. The formula is just important. 1 by f1 plus 1 by f2 minus d by f1, f2. And you keep this lens at a distance of d by f1 f equivalent. Mains level question, a direct result. Generally, we won't get any problems on this. Because if at all, if they are trying to ask you any problems on this, you generally what you do, you can just treat it as two lenses, right? Find the image of the first lens, use that as an object for the second lens, and just directly solve it. But in CET, I've seen a question once like this. They gave two lenses and they gave distance between them, and they said find focal length. You won't have time to derive in the HSC CET. Or maybe BITS or Manipal or Vellore. A lot of exams. Valid for parallel rays and common principal axis. This one and that Newton laws, both are kind of like that, just formula based. Newton's method for lenses and mirrors. Next thing, cutting of lenses. What happens if you cut a lens? So if you take a lens of focal length f, and let's say both the sides is radius r, if you cut it vertically, perpendicular to the principal axis, you'll get two pieces like this. What do you think will happen to the focal length? Remember, if you add these two lenses, 1 by f1 plus 1 by f2 must be equal to f, isn't it? So this will be double 2f and 2f. So 1 by 2f plus 1 by 2f is 1 by f. The focal length will double whenever you cut vertically. Another way to say this, the radius of curvature will become r on one side and infinity on another side. Na? So it will be 1 by r1 minus 1 by r2, that r2 is infinity. So focal length will double. Same lens, if you take it and cut it along the principal axis. In this case, the radius of curvature does not change. The focal length remains same. So cutting it along the principal axis won't affect the focal length, but cutting it vertically does affect the principal axis, the focal length. Suppose if you take this, you cut into 4 pieces. And if you keep all the 4 pieces together, then what will be the focal length? Just now I told you, if you cut it vertically, it will become 2f. Horizontally, it doesn't change. If you keep all of them together, it will be 1 by 2f, 1 by 2f, 1 by 2f. It will be f by 2. What if you take the lens, you cut it in the along the principal axis, and you keep it like this? This is a good theoretical question, right? You should definitely remember the result. First of all, you can't use the formula 1 by f equivalent is not equal to 1 by f1 plus 1 by f2. Why? They don't have same principal axis. That formula is not valid. Then, if you think about this, look at this. When you send a light rays through a lens, you will notice something. The light rays which go above the principal axis, they bend downward. The light rays which go below the principal axis, they go upward. That means if you try to send a light ray through this system, so if you send a parallel light ray, it will get pushed down. This bottom one will push it up. Again, you'll get a parallel ray. So if you send a ray and it comes out parallelly, what is the power? 0. And focal length is infinity. Clear with this? Only for this case you can say that, because this principal axis are like this. Symmetry. The D is a good one theoretically. You can't solve that normally, but yeah, you can show it from the light rays perspective. The upper one will push it down, the lower one will push it up. So by symmetry, the light ray will come out parallel. Any doubts on this page? Clear, Rehan? Pushkal? Ansh? Arush? Ahana? Next thing. Number of images in a lens. This was asked in matrix matching. Easy one, but yeah, they do ask. In an advanced paper, out of 20 questions, there'll be at least 5 to 6 which are easy. So let's say we got a lens which has two mediums, mu1 and mu2. Object is here. How many images will form? Suppose if you have a lens here, left side is mu1, right side is mu2. Now how many images will form? Let's say lens is made into 4 parts, mu1, mu2, mu3, and mu4. Now how many images will form? Let's say you have a lens like this, mu1, mu2, mu3, and mu4. Now how many images will form? So you just need to see how many unique light rays are there. If you see in the first case, light rays which go up, they will meet somewhere here. That's the image 1. Then the light rays which go through mu2, they'll act like a different lens. I2. So 2 images here. Agreed? What do you think about B part? So even though it looks like there are two different mu's, understand. Light rays which go up will go through mu1, mu2. Light rays below also will go mu1, mu2. There's only one image. Are you getting with this? You need to see when it goes from left to right, how many different mediums they're traveling. The up and the bottom both are traveling mu1, mu2. They're symmetrical. So just because you saw two different mediums, don't say 2 every time. What about this guy? Here also same thing. All the light rays above the principal axis will be remaining above the principal axis. That will be one image. That is the second image. What about the fourth one? Fourth is different. I can have a light rays only going through mu2. I can have light rays going through mu1 and mu2. I can have light rays going through mu3, mu4. I can have light rays going only through mu4. 4 images, isn't it? Making sense? So that was the reason taking that, unequal lenses. In the third case, because they're of equal radius, there was no chance if every light ray that goes through mu1 has to go to mu2. But here, fourth case, I can have mu1, mu2, I can have only mu2. Clear with this? So this is another type of things. Clear with this? There, that's a bit about combination of lenses and stuff. The next thing is prisms. Now in prisms, we have two parts. One is a regular refraction, and the second thing is dispersion and all. The dispersion is completely mains ka part, which we will do later on, after the portion gets over, we'll do that. There are a few chapters like that. Biomagnetism, right? This dispersion, diffraction, polarization, these things, I call them inorganic physics. You have to remember all those formulas and stuff. Semiconductors, you need to remember all that stuff, but they have 10% weightage in mains. You get 3 questions in mains. Advanced mein nahi hai, but mains mein hai. So that is that portion which is only for mains perspective. And those formulas, every year I tease them, but people keep forgetting it. So we do it in the end, and then we'll again, the last session of the revision program is that only. So 1 week before your mains exam, I revise them again. 3 easy questions you will get by time. So we'll see that later on. Next thing, so prisms, let's see the first part there. Listen to the derivation. Luckily, it is not there for HSC, it is there in 11th. 12th HSC mein nahi hai, but yeah, let's see how to derive this. You need to know your formulas and stuff. So a prism is made of transparent material. With at least 2 flat surfaces. This is a normal way of taking a prism. Now here we define something called angle of a prism. If a light ray hits this surface and goes off like this is your angle of prism. If a light ray hits these two surfaces and goes like this is your angle of prism. So we define something called the angle of the prism. So it need not be always that upper angle there. It is the angle between the two surfaces where the light ray is incident and emerges. So if you take even something like an hexagon, let's say light ray enters here, refracts here and leaves like this, then extend these two surfaces. This will be your angle of prism. Clear with this? So a prism need not be always in the form of a triangle. It can have any weird shape. You just need to extend the two surfaces and finish it off. No. There are like 3 to 4 formulas which are important to remember. Let's see the first one. This is your angle of prism. This is your normal. Let a light ray here enter at an angle of I. This is your angle of incidence. This is the refracted angle 1. This is your R2 and this is your E. Since that is normal, this will be 90 minus R1 and this will be 90 minus R2. Here you can see in that upper triangle, A plus 90 minus R1 plus 90 minus R2 is equal to 180. So we get A is equal to R1 plus R2. This is your first formula to remember. Angle of the prism is R1 plus R2, where both are the refracted angles. If you extend this light ray, it was supposed to go this way, but it has gone this way. So this would be your deviation angle delta. So if this is I, this is R1, this will be I minus R1. This is E, and if this is R2, this will be E minus R2. So from that triangle, we get delta will be I minus R1 plus E minus R2, which is I plus E minus R1 plus R2. And just now we saw delta I R1 plus R2 is A. So this is your second formula. The deviation is given by I plus E minus A. And if you also try to apply the Snell's law, we'll get mu medium sin I is equal to mu prism sin R1. Similarly, mu prism sin R2, mu medium outside sin E. I is your angle of incidence and E is the angle of emergence. Have a look at this page. Any doubts on this? So in IIT first year, right, you have a physics lab in this experiment. So they'll give you some prism and they'll ask you to find the refractive index. So all the story that we're doing is to find the refractive index of that prism. So you can also say it's an experiment in ray optics, the second experiment. Finding the refractive index of a prism using a deviation. So now when we got this thing, delta is equal to I plus E minus A. So normally when you do the experiment for different angles of incidence, you get different values of delta, you plot them on a graph. Delta versus I. This graph would look something of this sort. This is not a parabola. And if you observe here, the graph terminates on the left-hand side here. This happens because of TIR. Below that angle of incidence, there is no light ray which will come out, so that we don't study there. This point here is your minimum deviation. This occurs when I is equal to E. And we'll also notice something. For two angles, you get the same deviation. If this is I, you get the same deviation when again for E. That is because if I and E are interchanged, you still get the same deviation. Meaning, for example, if I is 40 and E is 60, if you make E 60, you'll get I 40. The graph is important. I'll show you how they'll ask questions on graphs also. And one more thing you will notice, when I is equal to E, delta minimum occurs. That means delta minimum will be 2I minus A. So we get I is equal to A plus delta minimum by 2. Then applying this in the Snell's law, mu medium sin I, mu prism sin R. And if I is equal to E, then R1 is also equal to R2. And which is equal to A by 2. Substitute here. There, this is the formula. So we get mu prism by mu medium sine A plus delta minimum by 2 by sine A by 2. This is how you can find the refractive index. So you have to do the experiment, plot a graph, find the delta minimum and substitute in this formula. Quite a useful formula. You should definitely remember this. There, these are the main ones. First thing is definition of angle of prism. You can't take any angle as A. A depends on which surface you're incident, which way you are refracting. A is equal to R1 plus R2. Delta is I plus E minus A. Then the graph and this. Have a look at this page. Clear with the derivation? Now here, so when delta minimum occurs, we got R1 is equal to R2 is equal to A by 2. So you'll notice the light ray becomes parallel to the base. So there was a question like this, I think in advanced, one of the more than one choice question. They said a right-angled isosceles prism is taken. For minimum angle of incidence, for the minimum deviation, the light ray inside becomes parallel to the base. True or false? A right-angled isosceles prism is used in an experiment. The minimum deviation has occurred. Is the light ray inside the thing is parallel to the base? A right-angled isosceles prism is used in an experiment, and for minimum deviation, the light ray inside becomes parallel to the base. And most people think, you see the prism and all, there is a case you're forgetting it. Let me show you. We just hear that word right-angled isosceles prism. Look at this thing. If the base angles are not same, this need not be true. If angles are not equal, light ray won't be parallel. So the statement which I asked you, it is not necessary. I never said the base angles are equal. You can have a case like this also, na? Right-angled isosceles prism. The angle of prism is 45, this is 90, and this is 45. Right? But when you say right-angled isosceles prism, people start assuming 45 is at the bottom. If it is an equilateral, then there is no doubt about it. Clear with this thing? So be careful. HSC book mein, they write this thing as if it is the actual statement, which is kind of wrong. If the base angles are not equal, the reason why HSC assumes it is right is because when you go to a lab, you always use equilateral prisms. So it works. In a standard prism is always equilateral prism. So HSC ka perspective is right in that way because in lab we use equilateral prism. But if I make a statement like this, right angled isosceles prism, then you're gone. Clear with this? Then we have condition for, did you see? I just taught you for 10 minutes and there are only 5-6 formulas. Mains ka portion will look like this only. Yeah, but prisms, so they do ask even in advance also. Condition for no emergence or maximum deviation. So I don't want you to remember the final formula. It's a little weird, but remember this thing. No emergence, matlab the angle of emergence becomes 90 degrees. Meaning it is almost at the verge of TIR. That's it. As long as you remember that, you can derive everything else. So the light ray enters here, goes here, and this light ray has become like this. So E is 90. So R2 is theta critical. This is R1 and this is I. Sin theta critical is 1 by mu. R1 plus R2 is A. So R1 is A minus theta critical. Sin I is equal to mu sin R1, which is A minus theta critical. So from here you get maximum angle will be sin inverse sin A minus theta critical. This is your maximum angle of incidence. If you try to send a light ray with more than this angle, it won't come out from the other side. There'll be no emergent ray. And this also will be the case of maximum deviation. Clear with us? Not difficult to derive, but difficult to remember them. So you should know what is happening. This is the main thing. Clear? The next one. This is again another thing to remember, maximum angle of a prism. So even that A has also has a limiting value. So this occurs, when the no emergence, that is the maximum deviation and the minimum deviation occur at the same time. Just think about it. It looks weird. The maximum and the minimum are same. Matlab kya? There are no values only in the middle, right? There's only one single value. It's there in HSE. So at the same angle of incidence, it became the maximum deviation and the minimum deviation. The picture would look like this. So you're sending the light ray almost at 90 degrees. It becomes parallel. Then again, it comes out like this. That's the meaning of the statement. I is 90. This became theta critical. This also became theta critical. This became 90. 2 theta critical is A, and so A will be 2 times sine inverse 1 by mu. This is your max angle of the prism. If the angle of the prism is greater than this, you will not get a ray from the other side. No matter what angle you send, the other side will get a TIR. So these words you should know. Till here it is fine standard stuff, but no emergence, max angle of the prism. So if you don't know these words, you will not understand what they're trying to ask. So these things that I have noticed, when these questions come now, people don't understand actually what is being asked. What do you mean by max angle of the prism? Nothing wrong. First time when I saw, even I was not understanding what the hell they're talking about. I started going through the HSC textbook. Then I found somewhere here. I said, okay, this is what they mean. Terminologies will matter. If you're doing in HSC, when you're preparing for boards, you will see all these terms. So unfortunately, this is the 11th. So 12th, you won't see. Boards is important. 80% of the portion in CET comes from 12th. 20% is 11th. Clear with this? And CET ka portion, right, does matches. If you see CET ka chemistry, it is exactly NCERT. So it will actually help you for mains a lot. That is the whole theory about the prisms. Questions will be straightforward on these formulas. Let me show you how they will ask. Let's have a look at this. Just go through them. Just formula substitution. Done. Look at this thing. A light ray passes through an equilateral prism. So he's saying A is 60 degrees. The angle of incidence is equal to angle of emergence, which is equal to 3/4 of the angle of the prism. He's saying I is equal to AE is equal to 3A by 4. Then we know deviation delta is nothing but I plus E minus A. So this will be 3A by 2 minus A, which is A by 2, and A is 30 degrees. Plus, the refractive index is useless. Look at this thing. It's also the same thing, direct formula substitution. Take this formula and substitute. So he's saying mu of the prism by mu of the medium, both are given 1.53 and 1.33. Sine A plus delta M by 2 by sine A by 2. Substitute that, you'll get the answer. Clear? So questions will be like that, straightforward. And there's one more thing here, thin prisms. This we will use in dispersion, and you'll also see this in questions. So what's a thin prism? If the angle of the prism is less than 5 degrees, we say it's a thin prism. So mu is equal to sine delta M by 2 by sine A by 2. For small theta, sine theta becomes approximately 2 theta. So we get deviation delta is A into mu minus 1. There. That's a deviation for thin prisms. Angle should be less than 5 degrees. Example, let's say if you take a prism like this, where A is 2 degrees and let's say mu is equal to 3 by 2. So the formula gives you delta is 3 by 2 minus 1 degree. Meaning if you send a light ray like this will deviate. Again, it's quite small deviation. This delta is 1 degree. That is the meaning of it. Okay. There was a question like this once. Then they say, there is a mirror here. So if you rotate the mirror by theta, the light ray becomes straight. What is theta? You get in the question, there is a prism, there is a mirror in front of it, right? So you sent a horizontal light ray, after passing through the prism, it hits a mirror, and the mirror is rotated by an angle theta, and the light ray becomes vertical. Then what is the angle rotated by the mirror? Think about it. If the mirror was straight, this light ray would bounce like this. If that is 1 degree, this is 1 degree, this is 1 degree. And this angle will be how much? 89 degree. Now you want the light ray to become vertical, isn't it? Matlab, you want the light ray to become vertical like this. So you want the light ray to rotate 89 degrees. Do you remember the statement? If you rotate the mirror by theta, then the reflected ray will rotate by 2 theta. So you should rotate the mirror by 89.89 by 2. याद आया वो result? Whenever you rotate the mirror by theta, the reflected ray will rotate by 2 theta. So first keep the mirror straight. You can see the deviation 89. So you want to rotate the light ray by 89 degrees. So rotate the mirror by 89 by 2. Clear? So you can play around like that. Questions would be of that sort. Great. Let's see one more question. Yeah, questions are straightforward on this, meaning they can ask some good one. This is a good one based on the graph. Unfortunately, all answers are marked. So let's prove them. Go to the last question. 49. A is 5 degrees. We still take it as small ray. The smaller, the better. That is the meaning of it. But if you give me 5, and if it's in the question it says thin prism, then take it as thin only. Generally, they'll use the word a thin prism. Look at this point here. This is delta minimum, isn't it? And that occurs when I is equal to E. So indirectly he gave you delta is I plus E minus A. Delta minimum is 60, I is 60, E is 60, so A is also 60. Got it. Then the refractive index mu is equal to sine A plus delta minimum by 2 by sine A by 2. A is 60, delta is 60. So this is sine 60 by sine 30. Root 3. Second option is also right. What about C and D? Fine, I'll give you a minute. Look at this formula here. He's saying you're getting the same deviation here for two angles. That means this must be E and this must be I, isn't it? If you interchange I and D, you get the same deviation. So delta is I plus E minus A. This is 63 degrees. This is I plus this is 2I1. This is minus 60. We get I1 is 41 degrees. What about D? There, like I said, there's the same formulas. We're not doing anything big. What about D? He's saying for angle of incidence 70, the deviation of the light ray will be less than 65. What is 2I1? 2I1 is 82 degrees. That means this angle is 82, na? So 82 is giving 63. So shouldn't 70 give less than 63? Isn't it? There, that is all there in the graph. So for 2I1, 82 degrees, we get delta is 63 degrees. Therefore, for I, 70 degrees, delta is definitely less than 63 degrees. I don't know how much, but it's less than 63. So yeah, so less than 65 is true. All clear with this? These are the last questions in more than one choice. Then let's see the last one. This is not exactly prisms, it is just based on refraction, but yeah. Let's get this. It would be an integer question. This is our Draw the picture properly. That will show you a lot of things. He's saying it's almost hitting at a critical angle. So this is theta critical, 90 minus theta critical. This is 60. Let this be I, let this be 30, and this is 90 minus I. Right, Aditya. So this thing will be 90 minus theta critical plus 90 minus I plus 60 is 180. So we get I plus theta critical is 60. Next thing, if I apply the Snell's law there, mu sine I is equal to sine 30. This will be, I will be 60 minus theta critical is off. This is equation 2. And I also know sine theta critical is 1 by mu. Expand this. So that looks like sine A minus B. Sine 60 cos theta critical minus cos 60. Sine theta critical is off. Sine theta critical is 1 by mu. Then cos theta will be root over 1 minus sine square theta. Root over mu square minus 1 by mu. Root 3 by 2. Root over mu square minus 1 by mu. This is half and 1 by mu. 2 goes off, mu goes off. Root 3 root mu square minus 1 is 0. Seven, that's what is being asked. X by 3 whole power half. Check it out. Once I wrote this equation and this equation, physics got over. Just start to expand sine A minus B and substitute everything. This is nothing with the Prism formulas. It looks like a prism, so you have to be careful. One simple thing to see is this. In a Prism formulas, the light ray always comes back from here, right? There was never a TIR. The moment you see TIR, forget about prisms and just use your Snell's law on regular problems. That is a thing. Keep that in mind. Just because you see a prism doesn't mean you have to use Prism formulas. Clear with this? There. That is a little about prisms. And after this, like I said, there's a dispersion and all that stuff. All formulas only for mains. We'll see later on. With that, we are done with the chapter also. We did almost 50 questions. So make sure to go through this. In case you have not solved any material before on ray optics, please do your classes ka material and do your HCB. In case you have already done the material before, then you can do the sheet which is sent in the group. That has around 75 questions. All advanced level questions had solutions also. Just do that. That will be a good practice. That should be sufficient. Okay. With that, we'll wrap up for the day. Next class on Friday, when we catch up, we'll be starting off with magnetic force. So we have 3 parts there: magnetic force, magnetic field, and bar magnets. Again, bar magnets is for mains portion that we'll see later on. And after that, we'll go with EMI, AC. So entire electromagnetism will be done with that. Then we are left with waves and wave optics and modern physics. That's your advanced portion. Then we have chota topics, bar magnets, semiconductors, all these is mains ka parts. That is okay. That we will finish off in a week or 2. Okay, with that, we'll wrap up for the day. So any doubts in the class notes, anything else, please stay back and ask, or else you're free to leave. So I'll see you again Friday, same time. Take care, stay safe.